Viewers, we are back to our lesson on plane geometry with the subtopic angles. In our last lesson, we've looked at definition of angles. I've also explained what we mean by plane geometry. From there, we look at definition of angles. We also look at parts of angles. Then we also try to look at the various types of angles in our last meeting. And I've also given an assignment. Besides that, in our last meeting, I also asked you to go and look for another term for angle on a straight line. Angle on a straight line. And today we are coming to continue. So with regards to angle on a straight line, it is also called straight angle. Straight angle. Straight angle. Let me put it here. Straight angle. STRAIGHT. Straight, then angle. That's another term for it. Some also said we can also term it as individual angle. But what I know, or what I have researched about it, is straight angle. Straight angle. Alright, so let's move on to the assignment. The first assignment was find the value of the letters in the diagram below. So this diagram has been given. We have A, B, C. And on A, we can say let this point be O, this very point, because it has not been stated. So we can say let this point be what? O. So what happens is, if you look at this very angle, this particular angle is what is it? This is obtuse angle. Obtuse angle. It extends beyond 90 degrees. And when you look at this one, the AOB is also what? Obtuse angle. Fine. Now when you look at this one too, this angle, it also extends beyond 90 degrees. So it can also be what? Obtuse angle. And we know that when you add this one, this angle, this angle, this angle, they form what? They form a straight line. This angle, they form a straight line. So, sorry, I said straight line, sorry. They form a circle. When you add this angle, this angle, this angle, they form a circle. And when an angle make round, or when an angle move round, in our last meeting, I said it is also called what? Full rotation of an angle, or revolution. So revolution is what? 360 degrees. So it means when we add this plus this plus this, we should get 360 degrees. To do this, let me take off this one so that we can get space for our calculation. So you can now say angle AOC plus angle, this one, AOB plus angle BOC equal to 360 degrees, because they form revolution. Because they form what? Revolution. Because they all form a complete circle. And when an angle forms a complete circle, it is what? Full rotation of an angle, or revolution. So here, And when you look at individual angles, the individual angles are obtuse angles. Where angle AOC equal to, you have to state it, 2x plus 40. Angle AOB equal to 10x minus 60. Angle BOC equal to x plus 30. So I think we can now clean this. And when we look at the question, we are asked to find the value of what? X. So let me clean this one. So this implies, so we swap in the figures. Two x plus 40 plus, which is this one, this angle. 10x minus 60 plus x plus 30 should give you 360 degrees. So here we have 2x plus 10x. It will give us 12x plus x. It will give us what? 13x. Then we add the numbers as well. 40 minus 60. Here is minus. So 40 minus 60 will give us minus 20. Minus 20 plus 30. It will give us what? Positive 10. Equal to 360. So 13x equal to 360 minus 10. This 10 will cross the equal sign to become what? Positive. So we have 13x equal to 350. So what do we, the next step is what? Divide through by 13. Divide through by 13. So x is equal to, so you get a particular figure. 350 divided by 13. So whatever you get, with the 350 divided by 13, whatever you get, you write it here. Then you now conclude, therefore, x is equal to that figure, or therefore the value of x is the figure that you get. So you can work it out and then get you get an answer. 350 divided by 10, you get a particular answer. Sorry, I'm not with calculator, so you can do it yourself here. In our next meeting, I'll try and work on that. Thank you. Viewers, as you are watching or as you are following my learning, you also don't forget to click on subscribe. Click on subscribe so that for the red distance to 10 white, or whatever color it is, but it should change from the red color. And also there is a bell. There is a bell beside the subscribe. Click on that bell as well, so that anytime my video comes, you get a notification. And also click on like. Like is the first thumb up. The first thumb up you see there, that is a like. Click on it. Click on the like. Then you can also comment under the video. You click on add comment. Then you can comment under the video. Thank you. Okay, so that is the first question. So let's look at the second question. Find the value of y in the diagram below. We have A, B, C, D. And when you look at this particular diagram, we have a vertical line and a horizontal line. When in our last meeting, I said when a vertical line and a horizontal line meet, they form a right angle. So here, this vertical line and this horizontal line, they form a right angle. So, and a right angle is made up of what? 90 degrees. All right, thank you. So here, the A angle BAD is y, is given as y. Then angle CAD is given as what? 5y. So here, and when you look at it, this is an angle. This one is another angle. But all these angles make up the right angle. So in our previous lesson, or in our last meeting, I explained, I said something under that when two or more angles add up to form a right angle, or add up to form an angle of 90 degrees, is called what? Complementary angles. So these are complementary angles, where we have the angle BAD and then angle CAD. They are all complementary angles. And complementary angles add up to what? 90 degrees. Okay. So here we have angle angle BAD plus angle CAD equal to 90 degrees because they are complementary angles. Because they are complementary angles. Okay. Where angle BAD equal to Y, angle CAD equal to 5Y. I think I can clean the question 3 for us to have space. Okay, so this implies Y plus 5Y should give you 90 degrees. And anytime you are working maths, make sure you have what we call clarity of expression, in that make sure you outline, in that your equal sign should be on the same line. Don't write equal sign, then do another equal sign at a different position. Let the equal signs be on the same line. In that case, it makes your work look neat. So here we have 6y, because y plus 5y. There is the coefficient of 1. So you add that 1 to 5, you get what? 6. You've done this under algebraic expression. So divide here by 6, divide here by 6. So y equal to what? So 90 divided by 6. 90 divided by 6, it should give you 15. So y equal to 15 degrees. So therefore, the value of y is, the value of y is 15 degrees. So we are done with the question 1 and then the question 2. So we'll be looking at question 3. Okay, so you can copy it. You can copy the question 1 and question 2, the solution to these questions as on the board. Okay, so let's move to question 3. Question 3, which I have gleaned right now. Let me read it from what I have here. Question 3. I said, if x and y are obtuse angles and reflex angle, respectively, find I, sum of x and y, I, values of x and y. If x and y are obtuse angle and reflex angle, respectively, find I, x and sum of x and y, I, value of x and y. Yes, I intentionally give this question just to make you think. So let's look at it. Let's first of all look at reflex angle and obtuse angle. This is what? This is a reflex angle. This is what? Sorry, this is an obtuse angle. This is what? This one is a reflex angle, right? So we can conclude that if you look at this, if this side is the obtuse angle, then this side can also be the reflex angle. I hope you have seen something like that. Or let me clean this one. If this side is the reflex angle, then this side will be the obtuse angle, as you can see here. So what did you see? You realize that we have a full circle. So what I'm trying to arrive is that when you add reflex angle to obtuse angle, you should get 360 degrees. I already mentioned this in our last lesson. Yes, I want you to go and also search on it. I want you to go and search, to also go and do more research. That is how we learn. Okay, so that is it. So when you add obtuse angle to a reflex angle, you end up getting full rotation of an angle or revolution. So here we can say that if x equal to obtuse angle, y equal to reflex angle, this implies x plus y will give us 360 degrees, because obtuse angle, because the sum of obtuse angle and reflex angle gives 360, or is 360 degrees. Is 360 degrees, or the sum of obtuse angle and reflex angle form a revolution. So you can put it this way, because the sum of reflex angle and obtuse angle form a revolution. So therefore, x plus y equal to 360 degrees. This is all what I want you to do for me. If you add the obtuse angle to the reflex angle, you should get 360 degrees. That's what I want you to do for me. That is all. That is the answer. So this is the answer for 3i. Now let's look at the II. The II says that means you have to find the value of x and y. This one, in math, you can't work for two unknown. These two variables, they didn't give any. So what do? You have to find any number for the obtuse angle, and then when you add it to the reflex angle, you end up getting the 360. Then you can work out for the reflex angle. So you can say that let x equal to. So here I just want you to show work. Just want you to see. Obtuse angle is an angle which is what? More than 90 degrees, but less than 180 degrees. So you can choose a number which is more than 90 degrees. So you can say let x equal to the obtuse angle equal to 100. You can't choose a number less than 90 degrees. And you can't choose a number equal to 90 degrees. Because 90 degrees from what? Right angle. So obtuse angle should be more than 90 degrees. It can be 90.01. It's still an obtuse angle. It's still more than 90 degrees. So let x equal to what? 100. So this implies 100 degrees plus y will give you 360 degrees. Because the two form what? The obtuse angle and reflex angle gives you a revolution, which is 360. So we have y equal to 360 degrees minus 100. This gives you 260 degrees. So therefore, if x equal to 100, y will be equal to what? 260 degrees. You can choose to represent with any number, but it will be more than 90 degrees if you are dealing with the obtuse angle. So you realize that the reflex angle, we say reflex angle is what? More than 180, but less than 360. So whatever figure you get for the obtuse angle, you definitely get an angle within the range for a reflex angle. When I say range for reflex angles, you start from 180 less than x, that is the value, also less than 360. That is what I'm trying to say. So let's say if you represent the reflex angle by, or you represent the reflex angle by, let's say the reflex, if you have to represent the reflex angle, it should be more than what? 180. So if you represent the reflex angle by 190 degrees, you now add x plus 190 equal to what? 360. So x will be equal to 360 minus 190. And 360 minus 190, it gives you 70 degrees. So x is equal to what? 360 minus 190, it gives you 170 degrees. Sorry, it gives you 170. 360 minus 190, it gives you 170 degrees. You see, that 170 degree is still less than 180, because obtuse angle should be more than 90 degrees, but less than what? 180. Okay, so this is the answers to the assignment I gave out in our last meeting. So today we are going to continue from where we stopped. And in our last meeting, I said when we meet today, we'll be looking at what? Properties. We'll be looking at properties of right angle. Properties of angles, or angle properties. We'll be looking at properties of angles or angle properties. Now, and the angle properties, we have the properties for the parallel lines. We have the properties for the quadrilaterals, in that order. We have the properties for these triangles. So today we'll be looking at parallel lines, properties for, or angle properties, parallel lines. Okay, please, you write what is on the board, then we continue. Okay, so let's continue. Now, in our basic schools, that is in our junior, our primary level or primary schools and junior high schools, we've learned that parallel lines are lines that do not meet. Yes, it's true. When you have any two lines that they can never meet, even up to infinity, they can never meet. Even if they extend beyond our physical, mass goes beyond the physical. According to this man, Albert Einstein. Albert Einstein bring mass to be something beyond the physical. So mass goes beyond, not even Albert Einstein, even in the Egyptian, the Kemet, they also believe, they deal with those, they started with mathematical principles, scientific research, and a whole lot of things. So mass goes beyond the physical. But what we do is what the physical aspect of mass. So when you look at parallel lines, they can go beyond our sight. They can go beyond our physical, but they can never meet. No matter what, they will never meet. Parallel lines will not meet. Okay. So we are going to look at angle properties. Parallel lines. Parallel lines, they are lines that do not meet. They do not meet, even up to infinity. They don't meet. Okay. So one, we are going to look at what we call, you see, when you have two parallel lines, and then you have another line that cut through the two parallel lines, that line is what we call transversal. Transversal. It is a line that cuts through two or more parallel lines. So when I have this line, when I have a line this way, another line this way, this arrow shows that they will never meet. That's the meaning of this arrow. So these are parallel lines. And I have another line that cuts through them. This line that cut through the two parallel lines is what we call transversal. This is transversal. So if here is A, B, C, D, E, F. So the EF is a transversal. So this is what? Transversal. Or transversal line. This is what? Parallel line. This one is parallel line. So let's take note of this. Now, anytime two parallel lines are formed and a transversal line cut through them, they make an angle. They make angles that are being enclosed. Angles that are being enclosed by the transversal line and the parallel lines. And these angles are opposite or opposing each other. Opposing each other, meaning they face each other. Meaning if one is here, the other one should be here. They face each other. But the transversal line divided. So when two parallel lines meet, when a transversal cut through two parallel lines, which make angles opposing each other, divided by the transversal line, these angles are what we call this property. We say they are what? Alternate. They are alternating. What I'm trying to say is you have these parallel lines, you have this transversal, I have an angle here, and the parallel lines. Then I have another angle here being enclosed by the transversal and parallel, but they are opposing to each other, and they are being divided by they are being separated by the transversal. So these angles are what we call, we say they are alternating. Alternating, meaning alternating can be, let's say, I am standing here, then another person is standing outside this very wall. Or I'm standing here, then there is a wall between us. Another person is also standing behind the wall, meaning we are alternating to each other. We are opposite to each other. But then there is a what? We are being separated by a particular medium, and that is a transversal. So let's take note of that. So this property, which is what? Alternate angles. Alternate. Alternate angles. Alternate angles. So alternate angles are equal and are enclosed by parallel lines, two parallel lines, and transversal. Alternate angles are equal and are enclosed by two parallel lines, and are enclosed by two parallel lines, which transversal lines cut through. Which transversal lines what? Cut through. So that is what? Alternate angles. And they are equal. And they have been enclosed by two parallel lines, which transversal cut through. So let's write it down. Alternate angles are equal and enclosed by parallel lines and transversal line. So when you look at the alternate angles, the angles are formed in a particular shape, and that shape looks like Z or Z. So let's write the definition down first. They are equal and enclosed by parallel lines which transversal cut through. They are normally covered by a Z shape. A Z shape formed as a result of, so add that one. I said they are normally covered by a Z shape. Then you continue, formed by parallel lines and transversal. Thank you. So we take down this example. We have this parallel line, another parallel line. So we have this one. This is this is in a form of Z shape. So we have X here, we have Y here. So angle X equal to angle Y, because they are alternate angles. For you to identify alternate angles, always try to find out if there is any Z shape. Example, if I decided to draw something like this, I hope you can see. Then I put this arrow. I put another arrow here. Then I put an angle here. Let's say A, or let me put a figure, 70 degree here. And I put, let's say, B here. Then I ask you to find the value of what? B. Very simple. Look at this parallel, this is another parallel line. But if you look at it, it's in the form of what? Z shape. So you can say that angle B equal to 70 degrees because they are alternate angles. Okay. So let's take down we'll solve one example. So if I say find the value of y in the diagram below, find the value of y in the diagram below. Here, if you have to solve this is a diagram. We have y here, we have 60 degrees here. We have A, B, C, D. Angle BAD is what? 60 degrees. And angle AD or ADC is what? Y. So you say angle BAD equal to 60 degrees, angle ADC equal to what? Y. So it means, so we have angle ADC equal to angle BAD because they are alternate angles. So this implies y equal to 60 degrees. Therefore, the value of y is what? 60 degrees. Okay, so let's continue. We also have another type in which whereby two lines, these lines can be transversals, whereby two lines cut through, they cut each other. Two lines cut each other, maybe it can be transversal, whereby transversal lines or two lines cut through each other. And they form angles opposite. They form angles that are opposite to each other. And these lines, they are in the form of what? X shape. These lines, they are in the form of what? X shape. So they form an angle, and these angles are opposite to each other. We call this type of angles vertical opposite angles. Vertical opposite angles. So we are going to look at the second property of parallel lines, where two parallel lines cut through each other to form X shape, whereby they make angles opposite to or opposing each other. These angles are equal, and they are known as what? Vertical opposite angles. We say vertical because if you look at the parallel lines, they are more or less vertical. They cross through each other in a vertical dimension. That's why we call them vertical opposite angles. They are equal and enclosed by parallel lines that cut each other or that cross each other in a vertical dimension. So they form X shape. They formed X shape. X shape. X shape. They form X shape. Please write it. So when I have something like this, maybe A, B, C, D. This is one parallel line, this is another parallel line. They are vertical. They are in a vertical dimension and they form X shape. So if one angle is opposing each other and they are being enclosed by the parallel line, that cut through what? That cut each other. This one is equal to another. Just that they are in vertical dimension. So if I have here as A, B, C, D. So you realize that angle A will be equal to what? The one it is facing. They are opposite. They are opposing. The one it is facing is what? C. Angle C. Angle B equal to what? B is opposing what? D. Just that they are being enclosed by the parallel lines that cut each other in the form of what? X shape. Angle B equal to angle D. So these are the vertical opposite angles. Okay, so you write them down, then we continue. Okay, so let's continue. So if I have something like this, so find the value of the letters in the diagram below. So I have this one, parallel lines cutting each other, they cross each other in a vertical dimension. So if I put here, let's say here is 60 degrees. Here is X, Y, Z, or Z, X, Y, Z, Z, or Z. Okay, so I want you to find the value of X, find the value of Y, find the value of Z, or find the value of Z. They give you only 60 degrees. Alright, so we can say that to solve this, we can say that if you take the 60, which angle is it facing? It's facing the angle X. So we can say that angle, so how will you describe angle X? It will be A, you can label here as O. A, O, you can say let the center equal to O. So A angle, you can't just say angle AOD. No, you have to let the examiner, because the examiner didn't put anything there. So you have to let them know that you are labeling it as what? O. So angle AOD, which is X, we are describing X, AOD, equal to angle the 60 degrees. BO, because they are vertical opposite angles. Where angle AOD equal to Y equal to X, angle BOC equal to what? 60 degrees. So this implies X equal to 60 degrees. Therefore, so here you don't draw conclusion for now, because they say find the value. So now that we have found, we are able to solve for X. Let's try to solve for, now we know X, but then we don't know Z or Y, unless we know any of them, unless we solve for any of them before we can get the other figure, because Z and Y must be equal, since they are opposing each other, as they have been enclosed by the two parallel lines that cut through or that cross through each other by forming X shape. So here, now you can take angle A, you can take line AB. For you to solve for Z, take line AB, where the known figure is on. You can either take line, you can take line AB, or you can take line CD. So you say for line AB, we are taking this very line. That is what? Line AB. What did you see? If you take line AB, you realize that you have angle Z, and we have what? 60 degrees. This angle and this angle. It's more, forget about this side. Just forget about this side. Take this side for instance. The AB. You realize that angle Z and angle 60 degrees, that's angle AOC, and that of angle BOC. You see that they are on a straight line. These angles are on a straight line. And angles on a straight line, they are called what? Angles on a straight line, or angles that make straight angles, or angles that make straight angle, or angles that make angle on a straight line. We call them supplementary angles. And supplementary angles add up to what? 180 degrees. So we now say angle AOC plus angle BOC equal to 180 degrees because they are supplementary angles. Where angle AOC equal to what? AOC is given as Z, and angle BOC is what? 60 degrees. So once we know angle Z, we will know angle Y. So angle Y is what? BOD. Good. So this implies we now know angle AOC as what? Z plus 60 degrees, which is angle BOC, equal to 180 degrees. So Z equal to 180 degrees minus 60 degrees, and this gives you 120 degrees. Now we are done with angle Z. Also, angle Z is described as what? AOC. Angle AOC is equal to angle BOD. That's angle Z once we have written them down. Because they are vertical opposite angles. So this implies where angle BOD is what? Is given as Y. So this implies Y equal to, because we know angle Z as 120 degrees. So here our figures, the value of X is 60 degrees, the value of Z is 120 degrees, and the value of Y is also what? 120 degrees. So we can now conclude therefore the value of or we can just say therefore X equal to 60 degrees, Y equal to 120 degrees, and Z equal to 120 degrees. So these are the figures. So you realize that even though we were dealing with vertical opposite angles, we end up working alongside with straight angles or angle on we end up working alongside with a supplementary angles on a straight line that sum up to 180 degrees. So these properties of angles, types of angles, you need to know them on your fingertips. You need to know them. You don't need to memorize them. You need to understand their basis. You know, when we say alternating, meaning when two parallel lines, when they are cut by a transversal line, whereby they form Z shape, they are alternating. So the transversal line, one, and then the parallel lines, they have been covered, or the parallel line and the transversal line, they enclose, they covered to form, they cover the angle. Or the area they covered is form the angle. So when these two angles are opposing each other, and they have been formed by two parallel lines, which has been cut by a transversal line, in a form of what? Z shape. Z shape. So if you want to remember alternate angles, just focus on what? Z shape. The moment you see letter Z, you know you are dealing with what? Alternate angles. You don't need to chew. You don't need to memorize it. Just know that when I see letter Z, I'm dealing with what? Alternate angles. Now, when you talk about the vertical opposite angle, we mean angles they are equal. Two angles that are facing each other, and it has been formed by two parallel lines that cross or cut through each other in a vertical dimension, which form X shape. So they form X shape. The two parallel lines they cross each other in a vertical dimension, and they form X shape. So the moment you remember the word, the alphabet X, you should know that you are dealing with what? Vertical opposite angles. So vertical opposite angle deals with what? X. X shape. Alternate angle deal with what? Z shape. So alternate Z, vertical opposite X shape. Thank you. So let's move on to the next property of parallel lines. Now we also have a situation whereby parallel lines, two or more parallel lines with a transversal line that cut through them. It's also in the form of what? Z shape. All right. But then there are angles that form on top of the parallel lines. Angles form on top of the parallel lines. This one, they are not opposite. But that's that the transversal lines, as the transversal line cut through the two parallel lines, you see some angles forming on top of these parallel lines. These angles are what we say what? They correspond, meaning they move along. So once this one is moving, this one is what? Moving. So when this angle is expanding, this one is what? Expanding. So we say they are corresponding angles. When this one is decreasing, this one is what? Decreasing. That's why we call them corresponding angles. So corresponding angles are equal, and they are formed on top of parallel lines, which has been cut through by what? Transversal. So you see that they are on top of the parallel lines, and they have been cut through by the transversal. They are not opposite. Just that they correspond. If one increase, another one increase. If this one decrease, another one what? The other one also what? Decrease. That's why we call them corresponding. Meaning they correspond to each other. So that is what? Corresponding angles. They form on top of the parallel lines that have been cut or crossed by transversal. So I think you can copy this. Then we move to that corresponding angles. Okay, so let's move to corresponding angles. That will be the 10. Corresponding angles, they are equal and form on top of what? The parallel lines cut through by transversal. So we'll take a look at this. If I have something like this, then I have A here, B here. Note, they can also form beneath the parallel line. So they can also form beneath, meaning they can also form below the parallel line. So let's take note of that. So if we have here like C, D, X, Y, Z, K. Angle A will be equal to what? Angle B, because they are on top. Now, here too, those that are on top is what? Angle X and what? Y. So angle X equal to angle Y, because they are also on top of the parallel lines. Then also, another one too will be what? The one that are beneath, angle C will be equal to angle D. But note, angle C cannot be equal to angle B, because this one is beneath, under. This one is on top, so they cannot be equal. It's only those that are under that can be equal. Those that are also on top, that can be equal. So take note of that. Angle C equal to angle D. Angle K equal to angle Z or angle Z. So those that are on top, they are equal because they correspond. Those that are beneath are also equal because they correspond. So take note of that. Okay, let's take some example, then we solve. Note, they can also form beneath B-E-N-E-A-T-H, beneath the parallel line. Okay. Again, find the value of the letters in the diagram below. So I have this my diagram. This is a parallel line, another parallel line, A, B, then C, D, then a transversal line, E, F. So let's say here I have 70 degrees. Here I represent here by X degree. I represent here by Y degree. I represent here by G, here by H degrees, here by K degree, here by F degree, and here by M degrees. So I've given only one. You have to find the rest. So here you can say let the point or let the vertex. The vertex is where the two rays meet to form an angle. So let the vertex equal to O. So here what can you see? You realize that angle Y equal to 70 degrees because they are okay, because they are what? Angle Y equal to 70 degrees because they are what? If we say angle Y This one, if we consider this, you see that they are in X shape. So you know that this one will be equal to, because forget about this one. Take this line, take this line to this level, this line. You know that they are in X shape. So this one, if y equal to 70 degrees, then it means they are vertical opposite angles. Then the next one will be those angles that are beneath, they form what? Corresponding angles. So we can say angle K equal to 70 degrees because they are corresponding angles. Then the next one will be, as we know K will be equal to F because they are vertical opposite. Angle K, angle F equal to angle K because they are vertical opposite angles. So this implies angle F equal to what? 70 degrees. Now if angle F equal to 70 degrees, we know K, we know Y, we know K, we know F. Now what next? But then we don't know X, we don't know H, we don't know G. We know this, we know this, we know F. Now, if you take angle F and that of, or let's take angle X, let's take angle K and X. What can we see? Take this line, line EF. So for line EF, take the transversal line or the transversal EF, just take it. Forget about the others. Just take EF. You realize that angle X and angle K, they are angles on a straight line. And angles on a straight line are supplementary. So you can say angle X plus angle K equal to what? 180 degrees because they are supplementary angles. So this implies, or where angle K equal to what? And we solve K and we have 70. Yeah, K is equal to 70 degrees. So this implies X plus 70 degrees equal to what? 180. So X is equal to 110 degrees. Okay, so now we know X, we know K, we know F, we know Y. Now, as we know F, we know X, indirectly we know what? M, because X and M are also what? Vertical opposite angles. So let me clean here. Let me clean here. So please write what is on the board for now. Write what is on the board. Write what is on the board. Okay. So I'm going to clean this one since we know the figure for Y on the other side. So now we can say that since we know X, we can indirectly know M. So we can say angle X equal to angle M because they are vertical opposite. So this implies angle x equal to what? 110. Now that we know angle x to be 110, when angles are on top of the parallel line, which has been cut by a transversal, these angles on top of the parallel lines, they are known as what? Corresponding angles. So we can now say angle x, angle h equal to angle x because they are corresponding angles. So this where x equal to 110, this implies angle h equal to what? 110 degrees. 110 degrees. So we now know angle h, we know x, we know f, we know m, we know k. The only angle we don't know for now, it seems we've worked for y. The only angle we don't know for now is g. And you can see that g is also beneath the parallel line. And m is also what? Beneath the parallel. So g and m are also what? Equal. G and m are equal. Because they are what? Angles that are beneath the parallel lines are corresponding angles. Okay, we saw for m already. M was 110. Yes, 110. So angle G equal to angle M because they are corresponding angles. Please, I'm going to clean this side. Where angle M equal to 110 degrees. So this implies angle G equal to 110 degrees. So we can now conclude that, therefore, so we follow the order. Therefore, the order in which we work it, we started with what? We started with K. No, Y. Therefore, Y equal to, or you can arrange them in alphabetical order, no problem. So in alphabetical order, we start with F. Therefore, F equal to 70 degrees. G equal to 110 degrees. H equal to 110 degrees. K equal to 70 degrees. M equal to 110 degrees. One, two, three, four, five. Okay, let with 1, 2, 3, 4, 5. Let with 2. X and Y. X equal to and Y equal to 70 degrees. So we are done with the third one, which is corresponding angles. copy what is on the board, then we proceed. Okay, so let's proceed. Now we are now moving to another section. We have an instance whereby, we have an instance whereby the power lines that has been cut, or two power lines cut by transversal, they have angles whereby an angle beneath, one angle is beneath, so one angle is under the top power line. Another angle is what? On top of the down power, or the power line that is down, that is under, or on top of the down power lines. Now the angle beneath the top power line, when you add it to that of the angle on top of the down power lines, we call them, they are what? They are inside. Those angles are formed within. When you look at them, they are inside. So we call them co-interior angles. We say co-interior because they are more or less like, when you say co, it's like two of us are doing the same thing. Two of us are doing the same thing, or two of us are in the same soup. We are all in the same soup. We are all in the same category. We are all in the same class. That's why co. In that order. Now, when you look at co, it comes from the word colleague. So now, if you look at these two angles, they are within the same category. They are all within. Interior means within or inside. So they are all within. And these co-interior angles, they are supplementary. Let's look at it. Because they are within, we said they are supplementary. So when you add the two, you end up getting, sorry for the interruption or the disruption. When you add the two, you end up getting what? 180 degrees. So the fourth one, co-interior angles. They are supplementary form within the power lines cut by the transversal or transversal. They therefore add up to 180 degrees. They are co-interior because they form within. So if I have this, I have another one here. Okay, I think let me put my drawings on top there so you can see it clear. If I have this, I have another one here. This is a transversal. This is A, B, C, D, E, F. Now, if I have an angle within here, let's say A is here, B is here. They are within. If I have another one here, K, M, they are within. So they are within. So that's why we say they are co-interior. And these they are co-interior angles, they are also what? Supplementary. So in that case, angle A plus angle B should give you 180 degrees. Angle K plus angle M should also give you 180 degrees. Now let's do some illustration here. Let's understand why is that, though they are within, but when we add them, we get 180 degrees. Let's get something here. At least this one is an illustration I'm going to do. If I have something like this, Then I have here, this is what? A. Let's say this A here is what? 20 degrees. What is a B? This B here is equal to, let's say, 160 degrees. Okay, let me even leave this 160 degrees. Let me leave it for the meantime. Now, let me say, so if here is 20, here will be what? If here is 20, this one will be, they are vertical opposite, so this one will also be 20. Now, if this one is 20, this one too will be what? 20, because they are corresponding. They are corresponding angles. If this is 20, this one too will be what? 20. They are under, they are beneath. So they are also what? Corresponding angles. Fine. And these are also what? Equal, because they are vertical opposite. Now, if this one is 20, then what about here? Here will be what? Here will be this plus this will give you 180. So because they are angles on a straight line, so here will be 160. If here is 160, here it will be 160 because they are vertical opposite angles. This is the X shape. Fine. Now, if you come here to let's assume that this and this, they are also what? They are also angles on a straight line. So they will add up to 180. So here will be what? 180 minus 20 will give you 160. Now let's come here to be 160. Okay, good. Now we say co-interior angles add up to what? 180 degrees, and they are within. So let's analyze it. Let's say this is B. So look at something. This is 20 degrees, which is the A. B is what? 160. 20 plus 160, 160. You get 180. Have you seen it? Now when you come here to, these angles are within. So they are co-interior angles, and they are supplementary. Let's prove it. 20 plus 160. What did you get? No, we didn't do the addition like this. So we use the other formulas before we end up arriving at these figures. So 160 plus 20 will give you 180. So meaning co-interior angles, we call them co-interior because it comes from the co comes from the word colleagues. And they are equal. They are within. They are formed within the parallel lines, which has been cut by transversal or the transversal line. So angles that are within, they are inside. They are within the parallel. They are, one is formed under the top or the first top parallel line. The other one is formed above the down parallel lines. So they are within. They are within. These and these are within. These and these are within. So that's what we call it co-interior. All right. So that is all about the co-interior angles. They add up to 180 degrees. Good. Now let's look at the last part of parallel lines. Instances whereby we have two or more parallel lines. Instances whereby we have two or more parallel lines that are cut or crossed by transversal. We say these parallel lines, they cut the transversal at the same ratio. Please copy these things before, but this one is just an illustration, just for you to understand why co-interior angles they add up to 180. Okay, so let me erase this one since we have written this definition down. So we're going to look at the fifth property. Instances where parallel lines cut, or where two or more parallel lines are cut by a transversal line. We say these parallel lines cut a transversal line at the same ratio. How? Maybe, yeah, we can have two transversal lines. We can have three or more parallel lines being cut by what? Transversal lines or transversals. We say they cut at the same ratio. If I have something like this, so parallel lines cut by transversals at the same ratio. So example, or for instance, I have these parallel lines. I have another parallel lines. I have another parallel lines. I have this transversal line. So maybe A, B, C, D, E, F, G, H, I, J. So parallel lines cut by transversal lines form the same ratio in size, in terms of the size. This one, not the angle, so the size. The size from what? The same ratio. So here, if let's say from this point to this point, if this point to this point is, let's say A, the size, A meters, or let me put X meters. Here to is Y meters. From here to here is K meters. From here to here is what? L meters. We say that they cut by transversal lines are the same ratio. So here it means the ratio of this is to this is equal to the ratio of this is to this. So how do we put it? The ratio of X meters is to Y meters equal to the ratio of K meters is to L meters. Meaning, when we take this whole line, this whole line as one line. Now, when we cut them into two, when we cut this line, this transversal line is being cut by the parallel line, we say that this particular line become a fraction of the whole line. This one to become a fraction of what? The whole line. If you are taking this one, this one, what is the label here? H gene is a full line. So half of H gene is what? Kx meters. Then here we have our Y meters. So we can say that a fraction of this with a fraction of this, when you pair them, if I pair this with this, should give me equal to if I pair K with what? L. I mean, I'm pairing them. So note, pair of the sizes of the same transversal equals pair of the size of the other transversals cutting the same parallel lines. So meaning this transversal line cuts the same parallel lines. Another transversal line also cuts the same parallel lines. So when I pair the sizes, when I pair this side with this side, should be equal to the pair of this side to this side. That's what I was trying to explain. The pair of the sizes of the transversal line that cut the parallel lines should be equal to the pair of the sizes of what? The other transversal that cut the same parallel lines. Take note, the parallel lines must be the same. The parallel lines that they cut through must be the same. So either 2 or 3 transversal lines, if they cut the same parallel lines, then the pair of their sizes becomes what? Equal. The pair of one side is equal to the pair of the other side, equal to the pair of the. Let's assume the transversal lines continue. Let's say we have another transversal line here. So the pair of this side, which will be equal to the pair of this one too. So when we are pairing them, we will now say that as we pair them, x is to y. It's the same as saying x over y equal to what? K over L. So it's a fraction. That's why we are pairing them. We are fraction of the whole line. Okay. So let's write what is on the board. Write what is on the board. We'll take one question and solve under this. After that, I'll give you assignment.